Welcome back, dear students. In this module, we are going to discuss some beautiful multiple choice questions based on Kirchhoff's law. So without wasting even a single second, let's try to analyze question number 1. The question is depicted as, in an open circuit and in a short circuit, we have. The options are as zero resistance and infinite resistance respectively, infinite resistance and zero resistance respectively, maximum current and zero resistance respectively, and the last option is zero current and maximum resistance respectively. So let's try to analyze. The condition given to us is open circuit and short circuit. So with going to the solution, what I have is, when we consider an open circuit, so by Ohm's law, I have V is equal to IR. Yes, dear students? Perfect. So I can also write your resistance to be voltage upon current. But we know, dear students, in open circuit, there is no path for the current to flow, implies my current is approximately 0, right, dear students? And if the current is approximately 0, when you substitute in the equation for R, what I get is V upon 0, which turns out to be infinite, right, dear students? Perfect. Implies your resistance in open circuit will be infinite. Now, can you guess what should be the case in your closed circuit? By the way, dear students, you can easily mark the answers. Yes, there is only one option which says that in an open circuit the resistance is infinite. But for our satisfaction, we will try to perform case 2 also. Now in case 2, when we have short circuit, there is no opposition to the flow of current. Implies the current will flow very smoothly, implies the resistance is almost negligible. And in an ideal case, dear students, the resistance is 0. That means in an open circuit the resistance is infinite, and in short circuit, or I can say in closed circuit, the resistance is 0. Hence my option B is correct. Right, dear students? Perfect. Moving ahead with our next question for this module. In the following circuit, the potentials at point A, B and C are 70 volts, 0 volts and 10 volts respectively. What I am supposed to find? It is not given us, but the hint we can guess is from the options. The options are, the point D will be at potential 60. Option B is, the point B will be at potential 20. Point D has two options, implies, dear students, that we are supposed to find the potential at point D. Your option C states that current in path AD, DB and DC are in the ratio of 1:2:3, and in the last option the ratio is reversed, that is from 3:2:1. Now, just understanding this question, the first thing that clicks to my mind is we have to find the potential at point D. So let's try to analyze. Can I say the potential at point A is given to me? Yes, and that is 70 volts. What about potential at point B, dear students? Yes, the potential at point B is 0 volts, and the potential at point C comes out to be 10 volts, right, dear students? Perfect. Now, let's assume a potential V at point D. Now, dear students, I know that from KCL, the junction at point D or the node has incoming current should be equal to outgoing currents. Implies I1 should be equal to addition of I2 plus I3. Right, dear students? Perfect. Now, but current can be written as potential difference upon resistance. Right, dear students? And if I say this, I am basically using my Ohm's law, which can be written as the potential difference by which my current I1 is flowing is from VA to VD. But VA is given to me as 70 volts. VD I don't know, so I'll put it to be V upon resistance. Similarly, I can write Ohm's law for I2 and I3. Now, when you resimplify this equation, dear students, what you will get is 70 minus V is equal to V by 2 plus V minus 10 upon 3. Now, can you guess? This is one equation and one unknown, so I'm supposed to find the value of D. So, when you resimplify and when you take your LCM common, what you will get is 6 into 70 minus V is equal to 5V minus 20. And moving ahead with this solving of equation, dear students, what lastly I will get is that your V turns out to be 40 volts. but oh, there is no 40 volts as the correct option, implies my option A and option B are incorrect. So let's try to find the ratio of the current, that is I1, I2 and I3. Now when you know what is the potential at point D, you can easily substitute in the equation of I1 so that your I1 comes out to be 3 amperes, your I2 comes out to be 2 amperes and your I3 comes out to be 1 ampere. Implies the current are in the ratio of 3:2:1, implies your option D is correct. So that's it for this module. Thank you.